time. I'm very sorry for this delayed start, but I'll just get going anyways. Just to give a brief background of what this talk really involves. I've been working in tech industry since last maybe about 15 years. I spent about 6 years working at Goldman, and then I started one of my own startup ventures, and then I ended up starting a digital agency. While I was working with digital agency, that is when first I encountered cryptocurrency. I invested a little bit in Bitcoin. This was back in 2014. In 2016, end of 2016 is when I first bought Ether, and that's when I first encountered like blockchain. So until then, I wasn't really following blockchain, but I was more like just playing around because of my banking background with cryptocurrency, like in general. So I was just trading in and out, and that was pretty much it. Can everyone hear me?
I prefer that you put
The mic, okay.
Just got a radio, every pop on you.
This one? Yeah. I'll just turn it off. Is it better now? Perfect. Okay. So I was just saying that I was playing with cryptocurrency since 2014, but I really started playing with blockchain end of 2016, early 2017. When I first saw blockchain, I was like, what is so special about this? This is just a linked list. Like, I've read this data structure back in 2003 when I was doing my engineering. So what's so big deal about it? And as I started experimenting with it, so because I run a digital agency, a client came to us. They wanted us to do a POC with blockchain, and that really gave us like our first opportunity to start working with it. At the time, I started playing with a fork of Bitcoin blockchain. Now, as we were deep diving into what this technology is, what is the consensus algorithm is, how do miners actually come in, how do they validate their transaction, that's what really intrigued me more about blockchain. Now, after we did that POC with the Bitcoin fork, that was the end of the project, and that happened continuously with all the blockchain projects that we did that year. So like all 2016, 2017, we were playing with blockchains like Bitcoin forks, Ethereum. So we did a lot of smart contract writing on Ethereum, and that was mainly due to all the ICO buzz that we saw in 2017. Late 2017 is when we started experimenting with Hyperledger. I'm assuming everybody over here is aware of what Ethereum is, what Hyperledger is, say what Lisk is, Ripple is. Is that a right assumption to make? Yeah? No? Okay. So Ethereum is a pseudo-anonymous public blockchain which facilitates you to write smart contracts. So it's little bit more advanced than just having a data store, basically. What is a smart contract? A smart contract is a sequence of steps that you write, and it's mostly like if-else, algorithm, basically. The smart thing about Ethereum is that it autonomously lets you execute that program on its own, and once you have deployed a smart contract on Ethereum, you cannot change it. So let's say when you went to company house and you said, I own this company, I want to do this transaction under this company. Now, if there is a smart contract, it will have a sequence of steps that you have to follow. Once those steps are satisfied, it will record that transaction, and then there is no way you can change that transaction. So it's, in a programmer's language, it's a standard if and else algorithm that we have been writing for years. It's just that because of the nature of the technology, once you deploy it, it's autonomously executed over there, and then you cannot change it. Like, you cannot go retrospectively and change what you wrote 5 years ago or a year ago. if you have to roll up an update, then you have to push another smart contract, which becomes like a version update to your previous contract. Hyperledger, especially Hyperledger Fabric, is an enterprise-grade blockchain framework supported by IBM mainly. So it's a federated private blockchain framework, unlike Ethereum. So when you deploy anything on Ethereum, anybody and everybody can see it. Hyperledger, because of the nature of the technology, you can actually decide who has access to what, so you can control the provisioning and the permissioning of it. There is Lisk, which has a concept of lot of side chains. So one of the challenges that blockchain community has been seeing is the volume of the transactions, the speed, the scalability, and because of the size of the blocks, especially on Bitcoin and Ethereum, it's not possible to store everything on the blockchain. So then people started doing a lot of off-chain and on-chain transactions. So they do not store everything on blockchain, but they will store something on the chain and then some things off the chain. Lisk supports that concept on its own by having a lot of side chains, basically. So Lisk is another blockchain framework. Now, while we are there, I think early 2018 or late 2017 is when we started working with few enterprises, and our criteria of identifying which blockchain technology we should be using changed. Because when we were working with companies who were just trialing blockchain for the technology, most of the time, the business requirement was, we want to go live as soon as possible. We don't really care about, is this platform is capable of handling, say 100 transactions per second. We are only expecting that we'll probably have 100 transactions a day, forget about a second. They did not really had requirements around, we want to store, say, 2 million records in the blockchain. They did not had requirements around interoperability. That if I'm talking with this corporate, then it should have an interface, a standard interface that it can talk to their infrastructure. However, when we started working with enterprises, that's when we started seeing the real meat. That are these blockchain really capable of actually surviving through all the requirements that generally an enterprise solution will have. Now, the different use cases that we came through and we did our prototype. So all of these solutions are still in POC stage. They are still in prototype stage, because even though we have tested them in our lab environment for different transactions requirements, for different throughput requirements, they haven't really been tested in live environment yet. So only in lab that we have proven that this blockchain is capable of scaling to XYZ. One of the use case that we're going to go through today is a medical records, a typical healthcare use case for blockchain. So when blockchain actually came out, there was this report in, I think it was Deloitte that published that report, and it said that what internet did to media back in, say, 1990s and 2000, this is what blockchain is going to do to financial services and healthcare. Now, when a statement like that is made, and there are immense potential of using blockchain almost in all the industries. You think about logistics, you think about supply chain, you think about healthcare, financial services, obviously, tourism. There are talks about using blockchain in all those spaces. And one of the typical use case that we came across was using it in healthcare. We worked with a company that is currently working with an African nation. The problem there is healthcare, because it's state funded, and because of the type of structure that they have currently, there's a lot of corruption. So what they wanted to do was they wanted to explore blockchain as a means of storing all the clinical records of a citizen, and then give access to that via biometric verification, via face identification and recognition. And that's where first we started exploring different blockchain. By nature of the use case, we were looking at storing at least, say, 200 million records. We were looking at the assumption that if 1% of the population accesses their healthcare data in an year, then we are talking about 2 million, access. This could either be read and write. So let's say if there's 2 million access per year, we were anywhere looking at about 15 to 20 transactions per second. That's what it came down to. And that's when we started exploring, which blockchain will be the right one to actually support that use case. I don't know how many of you have followed, but Dubai is right now trialing a digital currency solution. It's called Mcash. And what they're trying to do is on all of their government outlets, be it school, be it paying any government bill, we're going to use, or people over there are going to use their Mcash cryptocurrency. So similarly, we did a prototype for another African nation who wanted to roll out a digital currency and see how that's going to pans out on blockchain. Not just rolling out of that currency, but it also wanted to facilitate transaction of that currency with other cryptocurrencies as well. So let's say Ether, Bitcoin, all of the main ones. And then there was this third classic use case for blockchain that's often talked about, which involves storing company records on the blockchain, be it for notarization, be it for just cross-checking, and then running it as a smart contract so that it can run on its own and can facilitate in decision-making on its own.
Sorry.
Yeah.
Regarding the Nigeria health records, so the solution, you wanted to go with blockchain for accessing the records. How is it different from the
Relational database. Yeah, so we'll come down to that actually on next slides. So I think when that company approached us, we actually asked them exactly the same question, why are we even using blockchain for this? Why can we not just use relational database? So, and I think that's the first question that I usually ask everybody to think, every client who approaches us and says we want to use blockchain. For example, one company came to us, they work in corporate messaging solution space. So their solution actually lets corporates install it in their premises and then have their employees communicate with each other. Now, they came to us and said, hey, we want to use blockchain in this. We want to explore how we can use blockchain. And the reason why they wanted to use blockchain was because one of the investors asked them, what are we doing with blockchain, right? And so they did not really knew, why they want to use blockchain. They just wanted to use it because it's a buzzword and because investors want that word in their architecture somewhere, right? So you will often have, different people come to you, different stakeholders come to you and say, we want to use blockchain in it. So that's first thing that we always try to ascertain, that why do we even need a blockchain in this space? Do we need it for facilitating, transparency? Is it for more security? Is it for saving cost? Is it for improving your transaction speed? So for scalability, for throughput, what's the objective? So in case of Nigerian company, this was more for offering immutability and saying that there is absolutely no way anybody can actually go in and change the record. If you use a traditional database, you can probably have logging mechanisms, you can have audit, you can have regulatory compliances, but the truth is that somebody can go and change it. There's no way you can avoid that. However, blockchain on its own, gives you that transparency and gives you that immutability because of the nature of the technology, that you cannot alter an existing record. You can update it, but then it will be a copy of your previous record, basically, and then you make an edit to it.
So when you do an update, how do you differentiate that the older record is now overridden by the...
So you have a version. So you say this is your 1.1 and this was your 1.0. So you can always have a tracing on depending on which blockchain you are in. Now, and I'll continue to use this Nigerian use case as an example. So different things that we were looking at while we were trying to finalize which blockchain to use. One was what's going to be my throughput? I mean, that to us was a bottleneck, question, because back in 2017, when it was a Bitcoin bull market, it took at least about 4 days to complete a transaction. With on an average, the transaction cost was about $28 to $30. If it goes to that, there is absolutely no way, we could have used blockchain in our architecture. So that was our first, question. Can we actually scale this technology? Can we actually use it as a data store, be able to access it, still in a reasonable cost? Can we actually optimize the solution so that we can bring the performance to a level where we want it to be? Can we look at parallelization? Can we look at off-chain, on-chain architecture? But how do we actually get the scalability and the throughput that we want? And that was our first question. Our second question was more about resilience. In a traditional architecture that we have been developing so far, we would always have redundancy. We will always have multiple servers so that if one fails, you have a failover, you have a backup, and you pretty much have a 24/7 uptime. What do we do in the case of blockchain? And whatever framework that we're going to use, does it supports that resilience requirement that a solution like healthcare industry would need? Immutability and data integrity. As I was saying, it was very important for us to make sure, because of the nation that's going to use and because of the structure of how the whole industry was operating and is operating, that we have a track of every single update that's being made to the record, and it's not controlled by anyone. So there are multiple stakeholders. Even if you have to do an update on an existing record, it needs to be permissioned, it needs to be provisioned, and that provision needs to be recorded in the technology itself. So that was another criteria that we had. If it's going to be decentralized, and is it a permissioned, a private, blockchain? Because of healthcare, because it's going to have sort of clinical identity of individuals, you cannot just let people access it. You have to have proper provisioning in place. So that's another criteria while we were looking at different blockchains. If you see so this is again a very simplified version of the whole architecture. But if you take a look at it, the way we envisioned this to work, so we did this, and here the server is set of microservices, not one monolithic server. And then there was blockchain, and then there's client. So this client are basically mobile apps and a web app. So the use case was, and the way we designed the structure was, that you as an individual, you as a citizen, will walk in, say at a clinic. If you do not have your identity recorded, then you'll register on the device. For registration, you'll have your biometric information, and you'll have your face print captured in the app. Once that happens, then we store that identity on the blockchain. The request goes via server. And here, this is a classic example of using blockchain as a data store, just for immutability purposes. So that gets stored, and then when I go again back at the clinic, I verify myself, the identity gets registered again, the access gets recorded again on the blockchain, and once the identity is verified, then the access to that record is open, and then the doctor or the clinic can perform the operations on that record for that individual. There are few challenges, and there were few challenges. So, for example, what happens if number of read requests are more than number of write requests at any point of time? How do we manage that? So then we included a queue mechanism and a prioritization of request. So all our read requests are prioritized over write request. The UI and UX of the mobile app and the browser was done in a way that when it comes to write request, it basically keeps letting the doctor know that it's going to take 5 seconds to update, it's going to take like 10 seconds to update, 15 seconds to update, just to manage users' expectation, versus read requests, given that they were always of high priority, we always ensure that they gets executed within a span of like 5 seconds. So at max, there can be a latency of 5 seconds, not more than that, on any of the requests. And then we tested it, I think, for about 50 requests at any point of time, like 50 requests per second throughput. The queue mechanism? No. No. Yes. Yeah. So for, and in this specific case, we ended up using Hyperledger Fabric. And the reason why we ended up using Hyperledger Fabric was because of its own hosting cost, because of the control that it gave when it came down to provisioning it, permissioning the access, the different type of nodes that we had to set up to support serving of that request, and in general, like, the community that was there around Hyperledger Fabric while we were doing this. So we were doing this project back in, I think, January 2018. That's when we started working on this. So at the time, it was also very important for us that the blockchain that we end up using has some community support, so that if there are questions, they can be answered, basically. So I'll skip the digital currency and I'll come back to it again. And then there was this company house data collector project that we did. Again, so the idea was, right now, if let's say you are director of a company, you can be director of like 5 companies, right? And even if you go on Company House website and you search and you ask how many companies is Vinita director of, there is no way for you to actually know that information. So the document is more around, this is the company, and these are the 5 directors of the company. These are the records. They're like, financial records that have been registered over the years. So your always top search will be around the company. What we wanted to do was restructure that in a flat schema, so that the queries can be made on any of the key parameters. So we wanted to run queries like, what companies Vinita is director of, what company Vinita was director of, how many director does this company has, give us the list of the companies that has more than 2 directors, 3 directors, 5 directors. So we just wanted to do that as a flat schema, and we did this project in partnership with the Company House. Again, the ask was simple. Again, because of the nature of blockchain, we ended up using blockchain because of its immutability requirements. And then, we stored, and we ended up using Hyperledger here as well. Because of the query. So one thing that I have learned in last 2 years is that irrespective of how good or bad technology is, 2 things are key players. One is the community, and second is the tools that technology is offering you. So it's not just about blockchain, but it's also about, is it giving you a tool to view its nodes? Is it giving you a tool to install it for you? And is it easy to maintain, easy to install, the hosting cost? And then, can you actually get an object browser so that you can just go in and see all the objects that are getting stored, and in what shape do you actually view them? And there again, we found out that Hyperledger Fabric is one of Hyperledger, the whole spectrum. So they have 4 or 5 tools. They have Burrow, they have Fabric, and they have 3 more. So that consortium in itself has a lot of tools that just makes your life very easy when it comes down to debugging and exploring the blockchain itself and the data store. So here again, the use case was very simple. We used server. One thing that another key learning that we had was, it was almost impossible for us to eliminate server on its entirety. We always ended up having a server that would do caching for us, that would actually become our first layer when it comes to talking to all the client applications. Only in the cases of ICOs is when we were just having Ethereum, deployed our smart contract, people used different wallets and interacted with blockchain directly. Otherwise, never in a mainstream solution we could ever just use Hyperledger, or just use, say, Ethereum or say Lisk, and just work off that, at least in my experience. So here as well, we used mobile apps, we used browser. So in this case, we actually had a web app that sniffed through all the database of the company house, took all those records, registered them on the blockchain via the server, and then because of the way the data schema was decided on the blockchain, different queries we were able to run via server again on that. And this was the digital currency solution. So this case is little unique to the healthcare example and to the company house example, in the sense that it involved interacting with multiple blockchain. So in this, when we did the prototype for this, so this is going to go in production early 2019. When we initially did the prototype, we played with Ethereum blockchain, we played with Bitcoin blockchain, and we played with Hyperledger. And when the reason why, and Ripple as well, so we had XRP as well. The reason why we decided to play with these 4 blockchain is because we wanted to see interoperability between these 4 blockchain. So a user can come in, they can use the currency that this solution offered, and it is called as love.cash. So they can actually come in, you have love.cash token, and you say, I want to sell 500 of these and want to buy one of Ether, like whatever the liquidity of the market is at the time. And the solution will actually allow you doing that. You can go to another exchange completely outside this platform. So let's say the token is listed on Binance. So you can actually go on Binance. You use Ether for your purchase, and you say, I want to sell my 1 Ether and I want to buy 500 of cash tokens. You do that transaction over there, and then you can push that 500 tokens that you bought over there to this infrastructure. So it had to be interoperable between different blockchains, and then different exchanges as well, like different liquidity providers as well. So let's say the first use case. I, as a user, I come to the system. I would do my registration. I would probably also enroll my Ether address, Bitcoin address, whatever wallets I have. And then I can actually do a fiat transaction. So I can say I want to give 500 of sterling and I want to buy cash tokens against it. The way you would do it is you would enroll your banking information, you would do your KYC, AML on the server. Once you have done that, you transfer your fiat from your bank account to the company's bank account. Once server has registration of that event that the fiat currency has arrived, it then basically goes to the private blockchain, and depending on, so there is a market data provider service on the server, which basically gives you the quotation of how much is worth what. Once it gets that data, it will then do the transaction on the server itself, but will store the transaction on the blockchain. So the reason why we did not use Ethereum in this case, so this could have been a classic ERC20 token that could have gone on Ethereum. The reason why we did not do that is because if we would have done on Ethereum, then we would have had to factor gas cost. And we wanted to eliminate gas cost for at least this type of transaction where we could actually avoid it. So we said we're going to have a ERC20 compliant token, but we would still keep it off Ethereum. We're going to manage the transaction of fiat to the token versus token to fiat back on our server. And because we're going to use a private blockchain such as Hyperledger, we can still provide the immutability and we can still provide the transparency, whatever is needed for regulations and for compliance. So the transaction then gets on the blockchain, and the good thing about Hyperledger is it offers you different event listeners. So you can always subscribe to an event listener, and you can say that if anything has been changed on this address, then push us an event. It will push you that event with all the event information. So you can bind your event with the wallet address. Every blockchain gives you an address where your records go in, and you can actually bind your records. You can bind your event register with that address. But the challenge with that is that if you have, say, 100,000 users, that eventually will mean that you have 100,000 addresses that you have to listen to. And that eventually will mean that you have to have observers for 100,000 addresses. And that itself, was a challenge. But then again, with Hyperledger, what we were able to do was set up different channels. So we were able to divide different users into different channels, and then we set up one channel, say, for every 5,000 addresses, depending on the frequency of the access and depending on frequency of the updates that we were receiving on those addresses. So and that event listener actually gave us a way to even listen to the transactions that were happening outside the system. So then what will happen is, let's say if you have an Ether address and you went off on another wallet, made a transaction on that address, then because you're observing that address, you'll get a notification, and then you can see what has changed, and you can then record that in your blockchain architecture as well. And that's how eventually we were able to integrate with Ether, Bitcoin, and with Ripple in this architecture. So we have a cache on the server, and that's so either via queues or via cache is how we were able to control the transaction that actually hits blockchain. So this is a sequence diagram when our client app made an update on blockchain via server, and that blockchain could be our own private blockchain or could be an external blockchain. So the blocks in the pink is external blockchain, and the idea was that it could be, as I was saying, it could be Lisk, it could be XRP, it could be Ether, it could be Bitcoin, or any one of out there. Cool. So in all of these, does anyone has any question?
All these use cases, I think the server is in communication with the blockchain. Is there any use case where one blockchain is having a communication with another, or it's just a storage?
No. So if you see this one, yeah, well, even in this one, because the observers were on the server, the event was first coming back to the server. So let's say if there was an update on an Ether address, it will come back to the server, and then it will go on the private blockchain. Yeah. So there was. You could potentially do it. You could, but then again, the question will be, what do you want to do with it? So say, for example, if I am. First, I haven't seen any connector where a Bitcoin blockchain is talking to an Ether blockchain. I haven't encountered that. In theory, you might write a smart contract that might let you talk to a Bitcoin address, but I'm not sure, will that trans-blockchain communication will happen, on two nodes? I don't think so. Yeah, I don't think so, yeah. Yeah. So I don't think you can. Cool. So our lessons, we made a lot of mistakes when we were designing this architecture. We went gung-ho with Ethereum like anything. Failed miserably when it came down to struggling with reducing gas cost. It was way expensive. We tried Lisk as well because of its sidechain concept. We just thought that if Lisk is giving us that ability where it has a lot of side chains and you can just put your transactions on the side chain and only keep your main hash on your main chain, and it will help you sync on its own, you don't have to worry about it. At least early 2018, late 2017, it was not matured enough. So we then again, and we wanted to keep ourselves away from Hyperledger. When we started, our goal was that we don't want to use Hyperledger in this project. We want to use something else. But then like it always came back to Hyperledger. Like, I don't know why, and even to date, so we started playing with EOS right now. It looks very promising at the moment, but then again, there are not a lot of systems in production right now that are using EOS. So it is still very early to say if it actually solves the problem that Ethereum had, especially because of its gas cost. So I don't think there was one blockchain that could put a tick against all the requirements that you would generally have for an enterprise application. You would have to compromise. For Hyperledger, our compromise was that it's a private federated blockchain framework. It's not an open public blockchain. Similarly, there are a lot of Bitcoin forks out there. I think Bitcoin is probably the most mature blockchain technology out there, and there are different forks because of that reason, out there. However, because these forks were created for a specific business problem, there are a lot of at least security problems in those forks. So you always end up hearing a report saying this fork was hacked because of XYZ. And so there was a big challenge on do we want to rely on a fork of Bitcoin that says gonna be really solving the problem that original chain has of throughput, and then end up with some security issue in your architecture that you never heard of and that you never had because there were not enough users of it. One mistake that we did while we were doing digital currency solution was that we were starting to use blockchain as our traditional database. So we started storing everything because we own the instance of Hyperledger. We just started storing everything without even thinking should it actually go in the blockchain or no. The result was that it started going slower and slower, and our hosting cost started increasing a lot, because then the only solution that we had was increase a number of nodes to increase throughput. And so then we became cognizant of the fact that even though we control everything within that framework, we still have to make the decision on what should go on chain and what should go off chain. And the most important one, as I was saying, that once you deploy something on a blockchain, you cannot change it. So you have to be really wary of what you are deploying, and if you're actually pushing it to production, there is no way you can roll it back. So you better test it properly, and that's why there are a lot of audit services that are out there who you can just give your architecture to have them review and audit your service, and then decide to actually deploy it in the production. One thing that I always suggest is do not rush into making a decision of which blockchain, and this is in general for any technology decision that you have to make, that always do your POCs, make sure that you have written down your metrics of what's going to be your criteria of pushing the app out to production. Is it going to be scalability? Is it going to be immutability? Is it data integrity? Is it provisioning? Is it permissioning? What are your main key criterias? And then based on that, test your POC, see if the solution, irrespective of what framework providers say, if the solution is actually delivering to what you're after. And this one about having a monolithic server versus microservices versus serverless architecture, removing the server at all. We tried different architectures. We tried doing pretty much going serverless, meaning not the serverless as in no server, but more with Lambda functions. We went with just having a fat server. I think the best choice that we made was start with the monolithic server and then break it down into microservices from that point onwards, rather than start with the microservices and then start combining them to a monolithic server. We just felt that breaking monolithic into microservices is a much easier decision to make once you understand your business domain better, once you understand your problem better, rather than just trying to think too much on different number of microservices that you want to have, and then struggling with scalability and deployment. So this is in general about Systango and Studio Fintech. So Systango is the name of the digital agency that I run. We have had the privilege of working with quite a few big companies such as Porsche, Target in Australia, Target in America. We're working with few companies in Australia as well. And then last couple of years, we started focusing on fintech, and we launched Studio Fintech that's specializing in fintech solutions and blockchain solutions. That's pretty much it. Thank you.